Hello. In this video, we're going to prove the sum and difference formulas for cosine. Now there are sum and difference formulas for sine and tangent as well, but right now we're going to focus just on cosine. So I have a unit circle sitting here, so this radius is meant to be 1, and I'll illustrate that by putting a point, we'll call it point A here, and it will be at 1, 0. I'm going to put several other points on this circle to help us do this proof. So I'll extend out here, and we'll call this point B, and we'll just give it the name x1, y1. Some x and y that we don't know. And we got to B by doing a rotation of v radians or degrees. Okay, I'll put a new point on there. In the second quadrant this time, it'll be point C, and we'll call it x2, y2. And that one will be from u minus v is what we're going to call it. And then I'll do a third point, or I guess it's a fourth point now. And I'll put that in the third quadrant. We'll call that point D, and that's at x3, y3. And that one's rotation will be u, radians or degrees. Now because this is a unit circle, the big thing to note here, if we remember that sine squared plus cosine squared equals 1, or if I just drop an altitude down to each of these spots, I'm going to have the distance over be x1 in this case, and y1 here. So we know certain things like x1 squared plus y1 squared is equal to 1 squared, or just 1. And that's the same for every single one of these. So x sub 2 squared plus y sub 2 squared is equal to 1. x3 squared plus y3 squared is equal to 1. So one big thing to note here as well is that the arc length, or the measure from A to C, has a length of u minus v. That's what we define that rotation as, u minus v. And the length from B to D has that same length, since this the rotation to D is u, and then to back it off we would take away the v radians that we rotated to get to B. So both of these have the same arc length, and therefore the segments that make them, so segment AC, draw that in sort of, try again, AC, and segment BD must be the same as well. So we know that AC equals BD as far as length. So using that to our advantage, we can use the distance formula to create the actual lengths for AC and BD. So the distance from A to C, we do the big square root for distance formula. We subtract our x's, so that's x sub 2 minus 1 squared, plus we subtract our y's, y2 minus 0 squared, and that's going to equal, and then we'll do this for BD. Subtract our x's, so x3 minus x1 quantity squared, plus, and then we'll do our y's, so y3 minus y1 quantity squared. And what I'm actually going to do here is just simplify this statement a bit in order to highlight some key information. And so continuing on with this, I'm going to square both sides first, and so square both sides, and square roots and squares cancel. And so knowing that those are gone, in order to make this a little bit simpler, I first have to make it a little bit more complicated, and that means FOIL. So x2 minus 1 squared, that's x2 squared minus 2x2 plus 1, plus y2 minus 0 is y2, and then squared is y2 squared, equals x3 minus x1 squared, that's x3 squared minus 2x1, x3 plus x1 squared. I'm going to run over here, but y3, so we're doing the last one, y3 squared minus y1, y3, oh, excuse me, 2y1, y3 plus y1, y1 squared. Okay, I'm going to group these together to show off a bit of information here. I'm going to group together the x2 and y2s that are squared. And so we have x2 squared plus y2 squared. I'll group those together. We still have our minus 2x2 plus 1 equals, and I'm going to do something similar on the right side. My x1 squared and y1 squared I'm going to put together, as well as the x3 and y3s that are squared. So x1 squared plus y1 squared added to x3 squared plus y3 squared. And then I have the rest of the stuff, so minus 2x1, x3 minus 2 y1 and y3. All right, so the x2 squared plus y2 squared, we already showed that that was the same as 1. So I have 1 minus 2x squared plus 1 equals, and then the x1, y1 is 1 that are squared, and the x3 squared and y3 squared sum to make 1. So that becomes 1 plus 1, and then minus the 2 x1, x3 minus 2y1, y3. Oh, okay, so if we subtract the 1's, so these together make 2, and these together make 2, and if we subtract a 2 on both sides, they're gone, and then I can divide everything by negative 2. And so we have x squared, or excuse me, x2 equals x1, x3 minus y1, y3. Now, using everything we know about cosine and sine, x2 right here is the same as the cosine value of our rotation. So x2, the rotation was u minus v, so that is the same as the cosine of u minus v equals x1 is the cosine value, and that first rotation is v, so that's cosine v. x3 is our cosine value of u, so times cosine u, minus the y1 value is a sine value of v, so sine of v, and then y3 is a sine value for our rotation u, so times sine of u. And so that is the proof of our very first thing, cosine of u minus v, that you see right there. Now to do cosine of u plus v, we're going to build off of this. We know that the u plus v is the same as u minus negative v, and so I'm going to plug that information in. So cosine of u minus v, I'm going to turn into cosine of u minus negative v. It's a v. And that's going to equal to, which just all that means is I'm going to replace all of my v's with a negative v. And so cosine of negative v times cosine u minus sine of negative v times sine of u. And by our various even and odd functions, so cosine, I can turn the minus, the negative into a positive, u plus v, and that's equal to cosine of negative v. Cosine of negative v is the same as just cosine of v, because v is cosine is an even function, times cosine of u. All right, sine of negative v is the same as the negative sine of v, because sine is an even function. So plus, that's supposed to be a plus sign. I'm running out of space here. So that's sine of v times sine u. Okay, and so we've proved both things. We are done. 10 minutes flat.